Okay, guys, we're in Advanced Math Trig, mods 2, 3, 4, and 7. It is Tuesday, May 19th, 2020, so top left corner of your notes, 5/19/20, May 19th. We're still progressing our way through quickly and accurately sketching all of our different kind of functions that we got to know as we head into next year. Today, the title says logarithmic. So every function we're going to try to graph is going to have a log in it, whether that be an ln, which is, of course, a natural log, or an log, which is a common log. It is still a logarithmic function that we're going to try to quickly sketch, okay? And we've only got 3 of them. This isn't a huge topic. A lot of times these are the ones, because they're less often used and not as familiar, ones that you are allowed to type into a calculator if they get any more complicated than the basics I've got here, okay? Let's go to block 1. First one says y equals ln x. And again, my goal is to come over here and just quickly and accurately draw a picture of that function. Now, if your instinct is to make an x and a y table here, that's fine, because we've been doing that a lot of times, and that's always your procedure if you're stuck and don't remember what exactly to draw to graph that function quickly. Notice here it's a little tricky. Pay attention to this. I would not start plugging numbers in for x on this problem. So if I randomly took a number like 3 and put it in for x, I'd have the ln of 3. Well, I don't know what the ln of 3 is. This doesn't mean a whole lot to me the way it's written, which is why we go back to, remember, our best friend when we worked with logarithms was always who? Ben. Remember Ben? Base exponent number. Every time I told you that you see a logarithm in a math problem, you think Ben. Now follow the bouncing pen here. I've got a base, and then on the other side of the equal sign is my exponent, and then whatever's next to the log is my final answer, my final number. So since this is an ln, do you agree that my base is e, my exponent is the letter y, equals a final number of x? So technically, if I'm going to try to graph this function accurately and quickly, I convert it or change it to make it look like that. So think about it. I'm not actually going to plug in. Okay, now let's think back to what we did yesterday. Remember, this was an exponential function. And what did we plug in for our exponent? We wanted our exponents to be -1, 0, and 1. Well, obviously, look, guys, y is our exponent this time, isn't it? So what do we want to plug in for the letter y? We want to plug in the 3 numbers, -1, 0, and 1, but notice that's in the y column. Let's start down here at the 1, and let's take 1 and go plug it in for that y. E to the first would be what? E, which is what? 2.718. That number I can put accurately. Let's take 0 and go plug it in for y. Anything to the 0 power is 1. Now careful, when I take -1 and plug it in for y, I'd have e to the negative first, right? Which is really 1 over 2.718. So it's really about 1/3. So I'm going to put approximately 1/3. So guys, we end up, when we draw this picture, plotting the 3 ordered pairs that I've now got on that XY table. I'm going to go over 1/3 and down 1, right 1 and up 0, and then right 2.718 and up 1. And it's a curve that flattens out that way and gets close to the y-axis here. Okay? So logarithmic functions are a little tricky in that you've got to kind of rewrite them into a form that's more usable. Let's see if that makes sense. Go to the second one. It says y equals the log of x minus 1. I'm going to try to sketch this graph. So I'm thinking I better make an XY table. But again, think about it. what numbers would you plug in for that x? You actually wouldn't. Even if I plugged in, let's say, a 2 and had 2 minus, this would say the log of 1, or if I plugged in a 3, it would say the log of 2. That seems confusing if I don't have a calculator in my hand. So again, guys, let's put a little arrow on this problem and use our friend. If you want to write Ben up there, we're going to use Ben every time. Remember, Ben means what? I've got a base, an exponent, and a final number. So on the word log, that's not ln, it's log, my base is understood to be what? 10. 10 raised to the y power, right? Equals, and then what's over here? X minus 1. Now, guys, notice we're trying to get the x to be by itself when we calculate our values on our table. So you're technically going to shove that 1 over, and we end up with x equals 10 to the y, and then if I'm adding over the 1, I'd have plus 1. And this is what I'm going to work with when I fill in that table. So again, this y is my exponent, and I always want my exponent to be what numbers? -1, 0, and 1. Does that make sense? So let's try it. I'm going to plug in the 1 first. What's 10 to the first? That'd be 10. Plus 1 gives me 11. So x equals 11 when I plug in 1 for y. Now let's plug 0 in for the letter y. Anything to the 0 power is 1 plus 1 gives me 2. Plug -1 in for y. What's 10 to the negative first? Now think with me, wouldn't that be 1/10? Plus 1 gives me 1 1/10. So I've created 3 points that I can plot and then graph my picture. Now notice I'm going to extend my x-axis here. Why? Because I notice we're going to plot the point 11, 1. So I'm going to go right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make sure you got enough room there. Plotting these 3 points, I'm going to go right 1 1/10 and down 1. Right 2 and up 0. Right 11 and up 1. So I've got a dot, and a dot. Takes on a very similar shape to that last problem, but we're going through there. We're going to flatten things out and continue down in that direction. Okay? All right, one more to go. This one's also a little tricky. Stay with me. Guys, look at the third problem I've got listed. I'm going to ask you a question. Just try to answer it in your own mind here. Why am I not going to use Ben yet? Oh, you don't think Ben until the logarithm is by itself. Noticed on the second one, the word log was by itself, and on this one we had a logarithm by itself. On this third problem, I've got a logarithm here, but there's also another number hanging around on that side that's got to get shoved over first, okay? So your first goal is to get the word log by itself, which would require me again to add over that 1. So I've got y plus 1 equals log x. And now that the word log is isolated, I can use Ben, can I? Ready? Let's change this into something we understand. I'm actually going to put it underneath here. Do we agree? Since this says log, what's my base understood to be here? 10. I'm raising it to the what? Y plus 1 power equals what value? X. So I did it. I was able to get x by itself. And this is kind of the exponential situation that I'm now going to use to create my XY table. Now careful, when I ask what numbers should I plug in, remember anytime we've got something raised to an exponent, we want our exponents to end up being -1, 0, and 1. So wouldn't I plug in -2 first, then -1, and then 0 for the letter y as my 3 values to plug into that exponent? Because, all right, let's do this. If I take negative 2 and plug it in for y, what's negative 2 plus 1? That'd be negative 1. 10 to the negative first is 1/10. Plug negative 1 in for that y. Negative 1 plus 1 is 0, and anything to the 0 power is 1. Plug 0 in for y. 0 plus 1 is 1. 10 to the first is 10. And guys, I've created my 3 ordered pairs to plot. Once again, I'm going to extend the x-axis kind of far here, because I am going to plot 1/10 comma negative 2. So I'm going to go right 1/10 and down negative 2, right 1 down 1, right 10 and up 0. So once again, we see the flattening of that curve and an asymptote being the y-axis, and you get a weird picture that looks like that. Okay? So now you've got the ability to look at a fairly basic logarithmic function, create a small table, and quickly sketch that graph to be able to work with it for next year. Okay? All right. Your 3 problems on your assignment. Again, today is Tuesday the 19th. So these 3 problems are due tomorrow on Wednesday the 20th. We've got the ln of x plus 2, 2 plus log of x. That's like the one I just did, right? And then the log of x minus 3. If you freeze and forget what to do, look at your notes. That's why you're keeping a good notebook to refer to and figure out the steps required to get these correct, okay? All right, great job. Tomorrow, I think we're going to review sketching of sine and cosine functions, and then we'll have piecewise functions on Thursday. We'll see you tomorrow.